Dr. D. Sangeeta is currently a senior lecturer at the Department of Chemistry, Anna University, Chennai. She has completed her PhD in the field of polymer chemistry from the University of Madras in the year 2000 and has teaching and research experience of more than 10 years. Her research interests are in the following fields: fuel cells for clean energy, functional membranes for desalination, and polymers for biomedical applications. She has published more than 20 research articles in national and international journals and has more than 40 research articles in national and international proceedings. Presently, she is guiding 6 research scholars for their doctoral degree.
Welcome to the UGC lecture series on the subject of polymer science. So, today we will begin with this particular unit covering various topics of this unit. Especially this polymer science subject will be divided into typically 5 units, beginning with the unit 1 where we will be talking about the fundamentals of polymers. The very basic concepts and issues related to polymers will be dealt in detail in this first unit, and a little bit information on the classification, what are polymers, what is the bifunctionality, how a compound behaves as a monomer and how does it undergo a polymerization reaction to form a polymer. Likewise, we will be talking about the very basic informations related to polymer materials. Unit 2 will be exclusively talking about the synthesis of polymers. Although we have several natural polymers available in this earth, we will be concentrating on this unit on the different synthetic or artificially prepared polymeric materials. What are the basic methods available to prepare such polymers? What are the basic polymerization techniques available? How do we follow them to prepare various artificial polymers will be elaborately done in this unit 2. Then comes your unit 3 where we will be talking exclusively on the analytical informations and the characterization results of a polymer. Here this important unit is taken over here in this particular subject because of the reason that whenever we take a polymer for a particular application, we must be aware of its basic properties, how they are going to behave in different conditions. For example, you need to know the thermal properties of a polymer, optical properties of a polymer, mechanical properties, conducting properties and biomedical properties and so on. Depending on the various analytical informations that we get from the characterizing procedures of these polymers, we will be able to know that whether they can suit a particular application typically or not, how sensitive they are going to be during their application site. Hence, this unit 3 becomes more important in terms of analyzing the various properties of the different polymers in order to suit various uses. Unit 4 exclusively talks about the processing of polymeric materials. Since we will be talking about the processing methods, here we will be concentrating on various synthetic or artificially prepared polymer materials, how they are prepared in an industrial scale or in a larger scale, how they are put to their forms, how they are being converted from their virgin polymeric material to an useful product. They will be given with different shapes, sizes, colors and so on, how these different sizes, dimensions are achieved, how they are processed into a particular form, whether they are formed as a tube or a sheet or a blowing bottle or a thin membrane, whatever it is, how they are processed into various forms will be seen in detail in unit 4. The conventional techniques that are utilized for the processing of the materials will be seen. Then unit 5 exclusively talks about the specialty of the polymers or those polymers which are being utilized for their special applications, and also the recent advances taking place in the polymer science, how they reach several applications right from commodity applications to medical applications, space applications, industrial applications, civil engineering applications and what not. All kinds of applications are being met with these polymeric materials. Their specialty or the special properties behind them will be discussed in detail in this particular unit 5. And today let us begin in this part 1 with the first unit, namely the fundamentals of polymers. Today we will look into the basic concepts of the polymer science. Now, in this particular unit we will be able to cover the following informations: that is, what is a polymer, how the name is getting derived, and what is a monomer, when do I call a particular compound as a monomer, how they become converted to a polymer, and what is constitutional repeat unit, shortly called as CRU, and how this CRU is different from the monomeric unit, and what do you mean by polymerization technique or polymerization reaction, functionality, which is very important. This is the basis or the basic necessity for a particular material to behave as a monomer in order to form a polymer molecule. And what is so important about the functionality property of a particular compound, and then we will be touching upon the degree of polymerization. What do you mean by that? How do you calculate degree of polymerization, and so on will be dealt. A little bit introduction to how we get introduced to the polymers. 20th century, the latest part of the 20th century, especially called as the plastic age, after the iron age and so many other ages before. In history, the later part of the 20th century is called obviously as plastic age because of the very important reason that we started making use of plastic materials in our every day-to-day activities. They are being used right from the morning, commodity materials, your cups, plates, spoons and brushes in your home, right from that to any automobile materials, any engineering materials, any civil constructions, biomedical applications, aircraft industries, your space industries, your furniture industries, everywhere the polymers and plastics have reached their elaborate applications in various fields. Hence, this later part of the 20th century was very rightly called as the plastics age and is still continuing in its application in our day-to-day life also. Then the synthetic polymers, they have almost become our activities in our daily activities, and then we do have what is called the natural polymers, those polymers which are naturally available since the origin of earth. These polymeric materials, especially the biomedical, bioorganic materials that are found in our body, in our earth's crust, in our plants, wood, trees and all kinds of natural origins have got these natural polymers within themselves. They form the basic constituents of all the living organisms. So, although we do have these natural polymers available in the nature, it is the synthetic polymers that has paved way for a great change in the applications of polymeric materials in various fields. Hence, there came the first synthetic polymer in the year 1860. The first polymer that was developed in this year was cellulose nitrate. In fact, this is only a semi-synthetic material that was developed, and later in the year 1910, bakelite was the historical polymeric material, which is nothing but the urea formaldehyde polymer material, was supposed to be the fully synthetic polymeric material that was developed during that year. Then now today, after 2000, we have realized that the conducting materials or conducting polymers have also been developed. The very basic characteristics of a polymer is an insulator. It behaves as an insulator. It does not conduct electricity, it does not conduct heat. But now we have come to an extent where we have realized that these polymers are equal to a synthetic metal even in terms of conducting properties. So, that is the kind of change, enormous change that has been achieved in the fields in the history of polymeric materials, right from insulation to conducting polymeric materials that are being used in different applications today. Now, let us go with all these important attractive features that are associated with the polymers. Why the polymers have become so attractive? What are these special unique properties that are pertaining to these polymeric materials? There are 3 or 4 important points to be noted very nicely. The first important attractive feature of any polymeric material is that they have got low density. They are lightweight in nature since they have very low density. This has given enormous change in terms of saving your power, saving your energy. When we were using metals and alloys, they were the conventional materials, they were very heavy and were not suitable for many applications because they will have to be taken, and a lot of energy is required in order to process them, in order to make them utilized for various applications. But now, since we have entered into the plastics age, the polymers materials, the biggest advantage of them is that they are light in weight, and hence the energy consumption for their production, transportation, usage, everything has come down, and this is the most important point of that. Secondly, all the polymeric materials do have very good processing character, that is their processability. This is nothing but the ability of the polymeric materials to get converted from the crude virgin polymeric material into different processing products, that is they are obtained in various forms and dimensions by using suitable processing techniques, and these processing techniques do involve various methods and they require less amount of energy when compared to a conventional technique that is utilized to convert a conventional material into its product form. Hence, these materials are very important because of their processing characteristics. They are easily moldable and also allows very easy production in a very large scale to happen. Another interesting point is that they are resistant to corrosion effects. They do not undergo corrosion, oxidation, as we have seen in iron and other metal species. Here, these plastic materials, since they do not undergo the oxidation, they are not attacked by the chemical reagents, they are not attacked by many of the acids and alkalis, they are inert in nature, and hence there is no corrosion problem at all. This is also another important advantage of the polymeric materials. Then comes their very basic insulating characters. They act as an insulator in terms of thermal as well as electrical. This is basically the polymeric materials are different from the conventional materials in having thermal insulation as well as electrical insulation properties. But of course, we have gone to a state now where we have even achieved the conducting polymer materials which are developing, and then various other special properties that can also be obtained in the polymeric material in addition to all the features which have been defined in this particular slide. Let us look into these special characteristics very particularly, very specifically in the final unit, how they are being utilized for the various special applications. Now, let us move on to what is a polymer basically. A polymer, the word polymer is derived from the classical Greek language, where poly means many, mers means parts. Hence, a polymer means many parts are joined together or linked together to form a big molecule, that is called a polymer. Thus, a polymer is a large molecule which is also called as a macromolecule because it is larger in size, hence the word macro, that is built up by the repetition of a number of smaller chemical units. Hence, a polymer is a big molecule also called as a macromolecule, which is basically consisting of number of smaller chemical units that are repeated several times in order to form a bigger macromolecule. Such a big molecule you call it as polymer. A large molecule that is made up of a number of repeating chemical units that are held together by way of covalently linked chemical bonds. Hence, all these smaller molecules which are repeated number of times in the same polymer molecule are connected through the bonds called covalent bonds between them, which hold them together in a particular state or form to form the bigger polymer molecule. The repeating chemical units that are simple and small, which is repeated number of times in the larger molecule called polymer, is called monomer. So, monomer is that particular smaller unit or that particular repeating chemical unit of a polymer which is repeated number of times to form the bigger molecule. Each repeating unit is called a monomer. Several monomers together form a polymer. A polymer molecule has long chains, very lengthy chains of usually several thousands of such monomers. So, it is several thousands of such monomers. When they are linked together, they form a big larger molecule called polymer. Hence, poly means many and mer means unit and polymer means many units. Here are few examples for you. This is the very simplest polymer molecule, namely polyethylene, CH2, CH2, N times, that means CH2 forms the monomer, and this is linked to several other n number of CH2 monomer units, and they form a big molecule, and this n is nothing but a number which tells you or indicates the number of repeating units present in the polymer chain. It tells you how many number of ethylene units or CH2 units are linked together to form the bigger macromolecule or the polymer molecule. Another example is here. This is your polypropylene. Remember, the basic structure we can remember as CH2 which is your polyethylene polymer. One of the H is going to be substituted with some other substituent, then it becomes a different polymer. For example, in this case polyethylene, one of the H is substituted or removed, and that is substituted by the methyl group. Hence, this becomes another polymer called polypropylene. So, the repeating unit of polypropylene is propylene, which is CH2CH3. Then the next polymer is polyvinyl chloride. Here again I am substituting one of the hydrogen in the second form over here. Instead of CH3, now it becomes chlorine. So, when I have a chlorine atom attached to this carbon atom where one of the H is removed, and if this is going to be repeated, the polymer I call it as polyvinyl chloride. Now, instead of Cl, if I substitute an hydroxyl group, that is OH, the polymer becomes polyvinyl alcohol. Here vinyl alcohol is your monomer and the polymer is called polyvinyl alcohol. So, with the monomer name, the word poly is always attached. The mer portion is your monomer, and the poly word, when it is going to be attached to it, it becomes a polymer. It is polyethylene, polypropylene, polyvinyl chloride, polyvinyl alcohol, and so on. Let us have a short break and continue now. Welcome back. After the short break, we were discussing about the very basic units of different polymers. We began with polyethylene, propylene, and now it is polyacrylonitrile. So, instead of one H, if I substitute a CN group here, this becomes polyacrylonitrile, shortly called as PAN. PAN fibers are very famous for various reinforcing applications, and this is going to be a bigger molecule which is called polystyrene. Now, this becomes CH2, CH, C6H5, a phenyl group is attached to that. Now, if this is going to be repeated n number of times, the polymer is now called as polystyrene. The styrene is the monomer, polystyrene is the polymer. Now, what is a monomer? Having seen the different configurations of very simple polymer molecules, now let us define what is a monomer. A monomer is basically defined as a simple molecule with two or more binding sites. So, these monomers are simple compounds or simple molecules with low molecular weight which possesses certain sites called binding site. They should have the capacity or potential to bind with the next monomer, other monomer. If they possess that capacity, it is possible for them to behave as a monomer and become a polymer. Hence, a monomer can be defined as a simple molecule with two or more functional sites or binding sites which allows them to bind with another monomer. Through such binding sites, they can form various covalent linkages throughout your structure with other monomer molecules. When you are going to have such binding sites, the capacity which is going to make the monomer to develop into linked products, this makes the monomer viable to attach with the next monomer in order to form a lengthy molecules. So, through such binding sites, they can form the covalent linkages with several other monomer molecules to form the polymer. Now, the number of monomers that bind together to form a molecule, now it is called as polymer, or macromolecule. Monomers hence become the very basic building blocks of all the polymers. If you talk about any polymer, all the polymers will have a very basic fundamental feature or a building block which is developed number of times, which is repeated number of times to form the bigger polymer molecule. Hence, all the polymers, they begin or start from the very basic fundamental block or unit called monomer. A monomer is any molecule that can be converted into a polymer molecule by combining with other molecules or other monomers of the same or different type. Now, these monomers, they have two things possible. One, they can bind with other monomers which are similar to them, or they can bind with different kinds of monomers. In that case, those monomers should also behave as a monomer by possessing binding sites or the sites which are possible to get linked with the other monomers. So, it is possible to form what is called a homopolymer, where the same monomer is being used to form the bigger molecule, or a copolymer. In that case, you have two different monomers, you have terpolymers, you have three different monomers, and so on. So, monomers anyway, they have the capacity to bind with other monomer molecules which can be similar to them or can be different from them, but they have the capacity to bind together to form a lengthy polymer chain. Some of the examples of monomer are given over here. They are vinyl chloride. Vinyl chloride forms polyvinyl chloride. Ethylene is a monomer which forms the polymer polyethylene. Propylene is another monomer to form the polymer polypropylene. Styrene is a monomer to form polystyrene. Adipic acid is a monomer which can form a polymer by combining with a different monomer. Ethylene diamine is also another monomer which can again form a polymer by binding with another type of monomer. So, here if you look into the difference between these monomers, they are all addition monomers which can add to itself to become a larger molecule, whereas in the case of adipic acid, we have the binding site in terms of acid groups, and in this case ethylene diamine, I have amine groups. So, these amine groups are acid groups or hydroxyl or whatever it is, they have the binding site and have the capacity to condense or combine with another molecule or a monomer to form a different repeat unit, which again could form as a bigger polymer molecule. Let us define all these differences in next few slides. Now, a polymer and a monomer. The properties of the polymers are entirely different from those of the monomers from which they are formed. Monomers are simple molecules with low molecular weight, hence their properties are entirely different, and when they form a bigger molecule of polymer, because the molecular weight increases, just because of the increase in the molecular weight, the whole of the property of the polymer entirely differs from the very basic monomeric units. Molecular masses of the polymers may vary from as low as 10 to the power 3, that is 1000, to 10 to the power 7, or even higher than that is also possible. So, it depends on the total number of repeating units or the monomeric units that are present in a particular polymer chain. Depending on the number of units, the length of the chain is going to increase, the molecular weight of the polymer is going to increase, and hence you end up with different kinds of properties which are entirely different from the basic monomeric materials. Now, when do I call a particular molecule or a particular compound as a monomer? The basic point is that when a particular compound is available to link its binding sites with other molecules to form a bigger molecule of polymer, then you can call that particular compound as a monomer. So, all the compounds or simple molecules cannot behave as a monomer. I cannot take it granted that every molecule can behave as a monomer. No, it is not possible. Only such molecules, only those molecules with 2 or more than that or more binding sites, which are also called as a bonding sites, can act as a monomer. So, it is a very basic requirement for any compound that they must possess minimum number of 2 binding sites or bonding sites to be available with them in order to act as a monomer or become a monomer which can form a polymeric molecule. For example, alkenes, diacids, diamines, diols, diisocyanates, all these can behave as a monomer because of their binding sites which are due to the unsaturation in these alkene molecules and due to the diacid, means 2 acid groups I have, it is bifunctionality. So, 2 binding sites I have in the monomer, so in the compound, so it can behave as a monomer. 2 amines are there, 2 alcohols are there, hydroxyl groups are there and 2 isocyanates. So, all these can behave as a monomer. In addition to this, more than 2 binding site, it is also possible for the molecule to behave as a monomer. Example, dienes, more than 2 unsaturations, polyols, more than 2 hydroxyl groups, polyisocyanates, more than 2 NCO sites. So, all these can behave as a binding site in order to form the polymer molecule. Such monomers, such compounds are only called as monomers. Now, what is a repeating unit? How this is going to be different from the monomer? A repeating unit is that particular unit that repeats itself to give a polymer chain, which is called as a repeating unit. This is slightly different from the monomer unit by the way that monomer is a simple molecule which has a tendency to undergo a polymerization to form a polymer. They have certain binding sites, but when they are linked to another monomer to form a polymer chain, their structure will be slightly different because there will be difference in the bonding site, there will be difference in the unsaturation or the groups that are available or attached to them. So, there is a slight difference in their repeating unit. So, that difference makes them different from the monomer, the repeating unit it is called as. Usually, the repeating unit is enclosed within a square bracket. Now, how this is again different from the constitutional repeat unit? Monomer, your repeating unit, and then your constitutional repeat unit. So, this constitutional repeat unit represents the repeating unit that is going to constitute a polymer that is going to be available in the structural form in the formation of the polymer. A constitutional repeat unit is different from a monomer. For example, let us take the case of a polymer polyvinyl chloride. The polymer PVC, it is shortly called as polyvinyl chloride, can be represented by CH2, CHCl, square bracket n times. N refers to the number of times the monomer is repeated. And now, the monomer which is available to form this polyvinyl chloride polymer is vinyl chloride. The vinyl chloride monomer can be written as CH2 double bond CHCl. Now, this is your bonding site and the the double bonds are available as bifunctionality or 2 bonding sites in the molecule. Hence, this molecule can behave as a monomer which in turn can form a polymer polyvinyl chloride. But how is this different from the constitutional repeat unit? Constitutional repeat unit is that particular unit which is basically constituting the formation of the polymer. Hence, here if you take this polyvinyl chloride CH2 CHCl, this is the repeating unit, constitutional repeating unit. Hence, this becomes CRU. The difference between the monomer and this is, this has a bonding site, a double bond is available, whereas the double bond is split into single bonds here when they are going to form a polymer. Hence, the structural unit present in the polymer, you call it as a constitutional repeat unit, and from which the polymer is formed, which has got the bonding site, is called the monomer. Here vinyl chloride is the monomer in this particular example. Now, polymerization. What is this polymerization? It refers to the chemical reaction in which a monomer is converted into a polymer molecule under suitable conditions. It is not possible to convert all the monomers, just put them together, make them a polymer. You have to find appropriate situation or find an appropriate condition where the polymerization can undergo, the monomers can undergo in order to form the polymer. So, there should be an initiator to initiate the reaction, so that the reaction takes place where there is a conversion of a monomer into a polymer that is going to take place. For example, an initiator is required by the monomer in order to undergo the polymerization reaction. Let us take an example here once again. N number of monomer molecules, here the vinyl chloride molecule is converted into a polymer, polyvinyl chloride, like this, with a constitutional repeat unit as stated over here. For this reaction to happen, for this polymerization reaction to happen, you need an initiator called peroxide initiator. Hence, only at appropriate and a suitable condition the polymerization can take place, where there is a conversion of monomer to the polymer molecule. Here are few more examples for you. Now, let us look into this particular example, where you have the ethylene CH2 double bond CH2, it forms polymer polyethylene. This is your ethylene glycol. This undergoes polymerization, the monomer undergoes polymerization to form polyethylene glycol. Now, look at the difference between these two reactions. This is a simple addition, this double bond opens and then it forms a single bond here and it simply repeats. This is called addition polymerization. One monomer adds to another monomer and the bonding sites are lost when they are linked together to form a bigger molecule called polymer. But how is this going to be different from this reaction? Look at this, I have two bonding sites in terms of hydroxyl groups. I have OH group this side and another OH this side. This is your ethylene glycol. When such a monomer undergoes the polymerization reaction, they form a constitutional repeat unit which is slightly different from your monomeric part. Now, this becomes a repeating unit, that is your CH2, CH2 and O, and when they link together, bind together, one molecule of ethylene glycol combines with another molecule of ethylene glycol to leave an eliminated product of water, H2O. So, here OH combines with your H here to form the H2O and hence the repeating unit becomes CH2, CH2, O n times. So, that is the condensation polymerization. So, this is your addition polymerization, this is your condensation polymerization, hence there is a slight difference between the first and the second. A little more advanced information we will look into the topic in the next part. Hence, today as a summary, what we have seen in part 1 is all about polymer, what is a monomer, how this is different from a constitutional repeat unit, and we have begun with polymerization. More detailed information on functionality or bifunctionality requirement, degree of polymerization and the polymerization methods will be seen in detail in the next part. Here are few questions for you. What is the difference between constitutional repeat unit and monomer? Identify the monomer and the constitutional repeat unit in polyvinyl acetate, polyethylene glycol and a commercial polymer called Saran A. For the Saran A case, I have given a clue here, it is polyvinylidene chloride. Please try out these monomeric forms and the different polymers. Thank you.